Good afternoon, everyone. My name is Alex Stinson. I am one of the owners with PROergonomics. For those of you that are not familiar with us or are not our client with us currently, PROergonomics is a consulting and training firm that specializes specifically in ergonomics. We have registered kinesiologists and certified professional ergonomists that specialize in ergonomics for their primary objective, so it's pretty much all we do. So we are very, very good at it. We have a long history of providing vast cost-saving initiatives and lowering injuries and providing return on investments for our clients, which we're very proud of. And we have really unparalleled customer service when it comes to handling our challenges that our clients are having. So before we get started on today's webinar, I would like to just inform that we are very happy to introduce this year's third annual IEC, which is our Industrial Ergonomics Conference. It will be held on June 7th this year, and we're very excited, and we'll be posting the content and the focus. The focus this year is bringing ergonomics into focus. So for all those of us that struggle with kind of getting to ergonomics because it has a tendency to fall off the radar because we're not dealing with ministerial labor, we're not dealing with critical injuries, we're hoping that the subject matter is going to provide you with easy, effective, practical ways to kind of inch it forward, because at the end of the day, we are still dealing with 42% of our injuries are musculoskeletal disorder in nature. So we are very excited, and hopefully we'll get to see some of you attend. And if you stay tuned to the end, there will be an offer. So today we are looking at trying to hold to a higher standard. And when we say hold, we mean that really, really literally, as in like holding a tool. So we're looking at our tool use. How are we using them in the workplace? Are we using them effectively? And are we creating potentially ergonomic challenges with those tools? So our agenda today is quite simple. We're going to be briefly talking about upper limb extremity injuries, talking about 4 simple questions that you need to ask that are going to get you to where you need to go. So we'll also be going through some of the guidelines that are out there for tool use and looking at some of the ergonomic solutions and next steps that you may want to consider. So although MSDs on a whole from year to year, we actually have been seeing a very positive decrease in musculoskeletal disorders. We are at, as I said, 39% for Schedule 1 employees and 42% for Schedule 2. And so still very high numbers, and the #1 leading cause of injuries in most workplaces. But when we're actually looking at upper limb and hand extremity injuries, we are increasing in how many we're seeing. So in 2015, we had 20.6. In 2016, we're at 23. So we're at 2.4% higher than we were a year ago. We have yet to know what the 2017 WSIB by the number report is, and we'll stay tuned for that and likely give you a bit of an insight when that finally comes out. So the question we need to ask is actually not just one question. When we ask the question, are tools ergonomic, that isn't the only thing we need to know. There are several cursory, preliminary questions that we should be asking before we can answer that, because often ergonomics is used as a huge marketing campaign when it comes to tool use, and rarely is it accurate. So there may be ergonomic features, but unless the tool was custom designed for the specific user using it, it is unlikely that it's going to be an ergonomic tool in all its facets. So when we're looking at trying to determine whether or not our tools are A, appropriate, B, causing injuries, and C, improving the overall task, then it's kind of a 4-step process that we need to consider. The challenge that we have as health and safety professionals is we are not the ones purchasing these tools. We are not the purchasing department. We are not usually the managers of the department. So we're not the lab manager or the parks and rec manager or the roads manager or the maintenance tool shop manager. So we rarely get to see tools until they're causing problems, which is obviously one step too late. So part of this is going to be, how do we look at finding out whether a tool is truly, quote unquote, ergonomic? And secondly is going to be start questioning, how can I make these tools more ergonomic when I'm not the person purchasing them? I'm not the one picking them out. How can I transfer some of this information and help or put in a process that's going to aid me with my claims and my job and making sure that the workplace really is a safer place? So when it comes to the 4 questions, it's pretty simple. First off, do they serve the function they were made for? Specifically when we start seeing tools with, oddly enough, that ergonomic tagline, often it is for a very specific feature in mind. So maybe it's the padded hand, maybe it's an odd angle, maybe they've redistributed the weight somehow, but what we need to make sure is that the hammer is acting like a hammer, because the hammer does something very specific that's supposed to take some of the stress and strain off the human body. Same thing with, are we using the need of power tools versus manual hand tools? We want to make sure that the function is really going to be worth not only the cost and the maintenance, but also that we're not going to be putting any undue hardship on the end user and thus our injury claims or costs. So is the tool working the way it's supposed to? Secondly, we need to ask, does the selected tool actually aid the task? So if we've introduced a tool that's either causing deficiencies in productivity or quality issues or errors, then we'll often start to see also a kickback on the musculoskeletal side, because that may be an indication that the user or end user is struggling with that tool and how they're using it. Maybe it doesn't fit. Maybe my job is to get inside a very small area and the tool provided to me is just too long to actually fit into that. And in which case, the tool that we've chosen isn't appropriate for the task. Thirdly, does it fit the layout? If we're looking at the layout, there's a couple of elements that we need to consider. First, we kind of go back to the task and look at, is the task a heavy, manual, a lot of labor required for that task? Is it more moderate and kind of assembly based, or is it more precision? Because that may dictate where the tool placement needs to be. We then start to see other things like power sources and that type of thing, which we'll talk about in a minute, about that are going to impact how the tool is able to be used, where it's able to be put, and how it's going to interact not just with the product that they're trying to assemble or manipulate, but also how the user is able to adapt to it. The last question we actually ask is, does it fit the user? And only when we actually can say yes to the first 3 do we actually get to the last one. And it's often because it's the hardest question to answer, because the previous questions aren't variable. Okay, the function of the tool is going to be static. It's not going to be changing. It's still a hammer is a hammer, a screwdriver is a screwdriver. And same with the task. They may have multiple tasks they may want to use the tool for, and you may need to ask the question, do I need more than one for all of these tasks? But the task itself is defined and finite. As is the layout, same as the task, may vary in that we have lots of different workplaces we have to address, but they don't continuously change. Whereas our user may. So we're going to have small females, we're going to have tall males, we're going to have changeover, we're going to have aging workforces, we're going to have injuries and accommodations. So the requirements of each of these populations is going to vary greatly, and it's always going to be changing. It's going to be, the wave in the ocean that just kind of comes out, the same water does not come back. So it's going to be our biggest challenge and always has been. So when we go through this webinar, a lot of these are going to be providing guidelines on how we can try and minimize how much variability we have, and we'll hopefully try and figure out how to best fit that user. The last part of this is to kind of go back and verify. So if you've said yes to all of these questions at the end of the day, and you think you've got yourself a really good tool, whether you ask the question right away or whether you give it a couple months before you ask it again, but you need to be able to verify that the tool is providing a positive impact, that it is improving your safety and decreasing your injuries, that productivity is either maintained or gone up, and vice as well, our quality is increased as well. So when we look at function, yes, we want to make sure that the tool is appropriate for the job. If we're going through a wall, we're not going to use a ball-peen hammer. That's just not appropriate. And it's going to actually increase the manual work required for the employee. So first, we address the appropriate tool. Secondly, we can then look at some of these quote-unquote ergonomic features. Some of them are good. The one we have addressed right here is one that can be definitely aid to minimize how much manual work and dexterity is required of the hand. So we've addressed and determined that, yes, we need pliers in this job. That's what we want. Now look for plier options that have some of the ergonomic features. So for instance, this one, yes, I have a manual effort to close. I want to make sure that that close is not crazy high force, but that I'm going to be able to close and get a secure grip. But the ability for it to open and for me not to have to weave my fingers and kind of open it manually is going to not only decrease the awkward postures of the fingers, but it's also going to, by half, reduce repetition and hopefully force as well. So we can start at the function level looking at some of the ergonomic issues, and that's one that we're going to definitely look at. So when you're considering your layout, things that can really throw your ergonomic design and your tool use and as much as your health and safety that you're trying to put into the workstation and thought process, if we have, as I said, the working heights are out of range, that's going to cause awkward postures. Simple things like you've provided a tool, but it needs to be plugged in and the power source is just far enough away where the cord is at its level. So they're constantly struggling and pulling against a cord to kind of be able to make use of that tool. Again, it's something to consider. Usually if it's something standardized like an assembly line, then it's not so bad, but some of our jobs, you know, in our municipalities or our maintenance shops where they're kind of working on benches and they're moving around a lot and things like that are kind of variable, that becomes challenging because now we're adding force to all the awkward postures. The space that we have, if we're looking at, you know, a similar picture to our gentleman here, you know, if he's working with that tool up inside, he's not going to have the room to get the torque that he needs to be actually able to use the tool, and maybe a manual tool is not really the way to go. So additional equipment, do you have exhaust or ventilation, which is going to be key, specifically if you have a lot of standing and that type of thing? And are you, in the space requirement of the power supply, are you looking at your cord length or your cord design even? I've seen some that are the spiral cording design that tangle terribly. And I see, you know, employees constantly struggling with a shorter cord length only because their cords got all kind of twisted up on itself and it shortened itself inadvertently. So we definitely have some of these considerations. They're not necessarily talking about ergonomics per se, but when they are not present, when we don't have the yes answer to that question, they're causing a huge ergonomic impact and creating more work for our employees and not less, which by definition is not what we're wanting tools to do. Tools should always be aiding the process and never hindering it. The other thing to kind of think about when we're looking at layout is what your surface is that you're trying to use the tool. This is a very common example of what we see kind of going wrong. The pistol grip tool, whether it be a manual tool or a power tool, is really only useful for vertical surfaces in an ergonomic way. So if we want that wrist to be straight and not to be kind of all bent over forward, then we need to be looking at a pistol grip if we're, let's say, drilling into a wall or drilling into a soundboard or something that is on a vertical plane in front of us. If that's the case, then a pistol-shaped tool is ideal. Otherwise, for the most of us, and we rarely see it, oddly enough, and if you have it, pat yourself on the back right now, because kudos to you, because it's not something that we see used very often. But most of our work is being done on a horizontal plane, and yet we'll still see these pistol grips being used. So where you would want to go if you have a horizontal plane is we actually want to see a more vertical kind of pencil-styled tool in use, so that we're actually able to, again, get that power grip, that neutral wrist posture in play, just like you're seeing at the top of the diagram. So when we get into the user, this is where some of the guidelines are present, and we can talk about those, but you can just start to see, just by this picture alone, the huge variety that is actually available to us. And I can honestly say, looking at each of these, I don't know. I mean, I know most of them, but I don't know specifically what all of them, what their ideal use would be. But it definitely could be a very fun day trip for someone to go out and kind of talk about if pliers are part of our process, and you're seeing the opportunity for some of these plier handle shapes or sizes or, you know, dimensions or soft grips, hard grips. How are they going to be used? And how are these bended, contoured, weirdly, oddly shaped tools going to be able to fit and potentially fit my end user better? Because what you see at Home Depot is really just scratching the surface with what you can get when it comes to tools. And it really becomes an important part of that end user. I have a client on today, and one of the things they were struggling with, and it's such a simple task, with scoops. And the scoop was basically just, you know, your average handle on the end, scoop at the top, scoop. I don't really even know how to describe it any further. But when you think about, if you're digging down into a bag of flour, box of sand, whatever the scooping material is that we're trying to divulge out, then we start to see, and you can imagine what the awkward postures of that wrist is. Yes, we have a power grip, which is ideal, but we start to see huge ranges of motion, awkward ranges of motion in the wrist. And if we're digging down, we're going to see them in the shoulder as well. So we want to start looking at different ways. And what we were kind of looking for in the end was, rather than having the handle just stuck to the end of the scoop, we actually wanted the handle to circle back over top of the scoop. So again, I could hold the top of it and then just scoop with my hand in a power grip and a neutral wrist. So one of the things you can do, if you are kind of interested in kind of digging a little deeper onto your options when it comes to ergonomic design, if there's a specific tool you're looking, something I do regularly, so I recommend others do it as well, just so I don't sound quite so crazy, is going on to your Google and Googling images for whatever the tool is. So ergonomic plier handle, or ergonomic, you know, screwdriver, and whatever it is that you're thinking could be a better design, and see what comes up. And it's a great way to start a conversation with your staff to say, you know what, this is available. Has anyone tried this? Would anybody be willing to try it? Because we're having a lot of these hand upper limb issues, and I'm just looking for solutions. Because as I said, what you're buying in from the store, what you're getting off the catalog at the very surface level, there may be better options available to you. There's also the question, you know, can it be manual? Should it be manual, or should it be power? If we're looking for any kind of forceful exertion, the answer usually is going to be power, because force is one of those risk factors that really elevates the opportunity for risk when it comes to injury. You know, when we have awkward postures, we have repetition, we have long durations of work, we have, you know, grip strength. All of those things come into play, and as soon as high forces comes in there, we kind of jump up a level with how people are going to feel at the end of the day, because the muscular exertion is that much higher. Weight of the tool is going to come into that muscular exertion component, if we're not conscious of the weight of the tool. And this is one area what I would say a lot of my clients over-engineer. We think the more robust, the longer it's going to last, the more better, return on investment we're getting more for our money. But the end user now has to manipulate, even if it is 1 extra pound. You got to understand that's most of this is one arm tool use. And from probably something that everyone is a little bit more familiar with, if you kind of take into consideration your tablet, okay? I used to use an iPad, very nice product. I'm sure most of you actually are probably on the iPad train. Unfortunately, I'm not. And one of the reasons was because, when you're trying to use a tablet specifically for work, your grip is not great. And the iPad is about a little bit over a pound heavier than the Samsung equivalent. And that pound made a huge difference for me. So weight's always going to be something that we need to question and kind of push the boundaries on. We always want the weight. We don't want to sacrifice the function. A sledgehammer is not going to be effective if it's not a sledgehammer anymore. But there is a certain weight requirement, but if we can challenge that to be as low as humanly possible, then as health and safety professionals, we've definitely done and put forth our best effort in minimizing injury. Other things to consider that become a little bit more challenging is your handle design. So we talked a little about the angles and the contours and the options there, and pushing how you can use some of those, because as I said, I'm looking at this picture going, I have no clue where that middle one on the left, I'm not sure where you'd use that. But I'm sure someone has or maybe knows, and that's great. Length is a big one when it comes to injuries. I'm kind of working backwards on my list here. When it comes to injury potential, if your hand tool finishes in the palm of your hand, then there is opportunity there for pressure on the median nerve, which could lead to carpal tunnel issues and other things like that. So we want to make sure that we have a length that's going to be appropriate for the user. Again, going back to that ergonomic challenging part where the user's hand's not always going to be the same. So we want to make sure that going forward, we have a length that maybe is variable. Maybe we have a couple of the same type of tool that has a different length, so that if there's different people that use it, they have different options available to them. If it is for the single tool, then maybe that becomes less of a challenge, because you can say, okay, well, this one definitely fits outside of your hand. We're good. We're not putting you at any risk. The diameter is another one. There is guidelines. We'll be talking about them shortly on what that diameter should look like. But from experience and talking with a lot of, specifically, your maintenance, very hand tool intensive industries, there is a personal preference there. And your hand tool diameter will dictate how much user force they use. So we all know, for instance, again, I'm kind of take a tool that's not quite as industrial as maybe a hammer or a screwdriver, and take your pen. So we have pens that are like our, the blue, very skinny, very slim and slender Bic pen. That is a very, very fine pinch grip to hold while you're writing. And the longer we write, the more effort and force we actually put on the pen, so that we're able to maintain our writing, clarity. So we'll then start to see, as pens get larger in diameter, that force actually becomes less. So there's things to consider. The smaller the diameter, the more force we are going to exert on the tool. And the longer we're handling the tool, the more force we're going to exert. So if you have both of those, long tool use, whether it be a pen, whether it be a screwdriver, whether it be a syringe, and we have a very small diameter, then we have kind of the startings of a lot of hand effort when it comes to doing. Looking at the diameter becomes potentially challenging if you're beholden to certain, or you're in a certain injury where you don't have that variability. But it's definitely something you can work with, and we'll talk about that a little bit later. Your tool material, something to consider. Again, it's going to impact how much grip force you use. It's also going to impact part of your more production quality error type side, because if you have slippage or contouring that's pushing in, we may actually start seeing maybe bruising or slipping of the tool, which could damage the part or the person that's in your industry. And so the material should be reflective of what you're seeing. If you're working in a very hot area, you want something that's going to be grippy. You're not going to want something that as soon as your hand gets, moist with sweat or condensation, that we're going to have errors and tools and increased grip force. So those are kind of the things when we talk about, well, not just weight kind of will go over power. Some of them will, all of them will go for power tools, but when we're speaking specifically to power, one that always comes to mind is vibration. There are standards out there, and we'll talk about them later or briefly. And if at the very outset your tool is not meeting that standard, then that may be a really good indication that we need to keep the search going for a tool that's going to provide a vibration standard that's less, because again, the ergonomic impact from long exposure to vibration can be very harsh and severe and long-standing with, white fingers or Raynaud's syndrome and, all the compressions of the vascular and nervous systems in the hands and forearms. Okay, so, and we talked a bit about kind of, again, going back to that work surface and the user and how it's all going to fit together that way. And again, oh, there we go. So we've asked ourselves our 4 questions. Hopefully we've determined whether we are looking at a manual or a power tool. So manual should be usually more precision. If you have restricted space where you're going to not have, to bring in electrical cords that are just going to extend the size of your size of your tool, and that your access is going to be either electrical, pneumatic. If you don't have those, obviously you're going to go manual. And again, when we're looking at power, anything that's high repetition, screw driving, if you have to do that a bazillion times, a screwdriver is going to have to do it a lot less. And same with force, whether it be grip force or torque force, and our consistency. So those are going to be 2 really easy questions, hopefully, to answer, is whether we go power or whether we go manual. So when we're looking at tool guidelines as far as weight, something that you're using one-handed, ideally we want to be less than 3 pounds. So if we're, oh, I'm missing some words there, I apologize. If we're looking at 2-handed tools, ideal is 8, limit is kind of 10. So we don't really want to go over that 10-pound mark. So when, again, you start thinking of some of our really heavier tools, specifically if you're in municipalities and you're working in road or parks crews, we've got a wrench here. I've seen wrenches the size of what seems like my body. And that's something you need to make out of material that's not going to be heavy if it needs to be that size. So keeping into consideration that 10 pounds, our precision tools, we want less than 1 pound. And we want to make sure that that weight is evenly balanced. So if you have something that's going to counter the actual function of the tool, and this sounds like something that would already be thought of because it would be engineered, but I assure you that, oddly enough, in the name of ergonomics alone, so we'll have someone who has said that, this is an ergonomic tool, and they've actually shifted the balance of the tool so that when it sits in the hand, it feels more balanced. But when you actually then put it into use, it becomes non-functional in what it's supposed to do. So for instance, a hammer, if you hold it in the middle, it feels better, right? If you're just sitting there holding the middle part of the handle of a hammer, that feels like a better distribution of weight. However, if you try to use the hammer while holding it in the middle, you're going to get all the work being done with your arm and a lot of impact, and it's just not going to be overly user-friendly. It's going to be poor, not only extending the task and making it more repetitive, it's going to cause more awkward posture, more repetition, more force. Whereas if you hold the end of the hammer and you're able to use the hammer with the leverage intended. So again, it's something just to be mindful of, because the number of times I've seen tool makers kind of advertising that this is a better tool because it has a better ergonomic grip. That's great, and that may work, but trial it first, because if for whatever reason that new grip that feels great when you first pick it up actually counters the actual function, then it's not an ergonomic tool at all. And actually, marketing when it comes to ergonomics is atrocious. It's not a word I like to see when it comes to marketing, because it's rarely the case. It's very, very hard to say something's ergonomic, because if it's ergonomic, it fits everyone. And that is a really, really hard claim to be able to put on something. We talked about your handle surfaces. So some of the things to consider as far as controls and making sure you're having a better tool. We talked about the angle, again, making sure that the tool is still functional with the ergonomic design. But we're wanting to make sure that we're avoiding a lot of contouring and ridges. So for instance, if you take consideration the handle surfaces, the pictures on the left-hand side of the screen, if you look at that middle one, you can see all those really tight kind of hills and like almost looks like a wave in that blue handle. How many people are going to be able to use that and have their fingers comfortably fit perfectly in those grooves? So for smaller individuals, they're going to have their fingers splayed way further than they maybe would normally like them to. And if they keep their fingers in a normal relaxed grip, the same thing is going to happen as a larger individual whose hands do not fit into those grooves, and that is they're going to start to see contact stresses in their pads of their palm and their fingers. So contouring can be useful. It can help with some of the slippage issues and the grasp and make things more secure. However, aggressive contouring is never a way to go, because it's not going to fit everyone. It's not going to be ergonomic. So we want to see if there is contouring, it to be much mellower and more rounded, and definitely not peaks and valleys like we're seeing in the blue handle, because we're wanting to make sure that if there is sculpting, that it's going to fit in a more generic way. So when we look at the handle length, as I said, we do not want it finishing in that palm of your hand. At the base of your hand, you can see where that red spot is on the right-hand side of your screen. So we're looking at something to be about 4 to 6 inches long. If you are wearing gloves, keeping in mind gloves are kind of contradictive to tool use because we have no tactile sense. So when we're doing a lot of hand activity and we're using tools and gloves, research has shown that we will actually exert more unnecessary force on the tool or the object because we don't have that tactile sensation telling us, our brain, we've got a good grip. So another thing to consider, if you are having gloves, you want to make sure that they are as thin as possible so that you're able to not have that unnecessary grip force, but still maintaining whatever the function is you need it to do for your task. So if you are having gloves, they recommend a 0.5 inch addition of length so that you're not having that issue of, again, contact stress into the palm and onto the carpal tunnel. Okay, we talked about the kind of hand design of the grip. If you're looking for a double handle, then we want it to be closed 2 inches, open no more than 3.5. And ideally, if we're looking like a power grip, such as your screwdriver or your hammer, we're looking at a diameter of 1.25 to 2 inches. This is something where you may choose to go to a smaller end, and I'll tell you why when we get to the end. But a smaller diameter might be more beneficial because you could put in a control that's going to allow it to be designed for a broader spectrum at a later date and more customizable. So we'll talk about that in a second. We're talking about precision. So when we're looking in lab works or jewelers or circuit board assembly, all of these types of things, even, just your maintenance shop where they're dealing with screws and that type of accessories, we want to have our precision grips. Our singles are, as it says here, 0.25 to 0.5 inches in diameter, and we want our pincer tools to be 2 inches spanned. And no more than that, because otherwise you're getting into just too much stress and strain on the fingertips. Because pinch gripping is generally one of our higher risk grips. A power grip is going to be our most comfortable and where we have the most functional use. But when we get into the pinch grips, we have, again, it's the same kind of analogy as the pen. The more slower the diameter, the higher the force. So when we are looking at vibration, if we know the tool is going to be something that's used regularly for an 8-hour day, some of the kind of simple tools out there could be that we have the, these are British, the HSE is the British or the UK standards for hand-arm vibration, which is 2.5 meters per second squared or 5 meters per second squared. And those you can find online in the spec sheet before you purchase. So when I've been going through and I've done tool assessments for others, not brand new. So if you can say brand new, that your tool at least started off within guidelines, then you at least have a good argument that even in use, we're going to start to see good ergonomic return on that. But I've seen specs in the tools where it actually shows, you know, your acceleration, your RPM at higher rates than this. So if your acceleration is higher than 2.5 or 5 meters per second, then we know we're starting off with a tool that's going to cause problems, specifically if they're using it all day long. So if you have less duration, then you can look down below, and this is kind of the guidelines that we have set out in the ACGIH and ANSI, which puts it into a little bit more perspective when it comes to less tool use. So it's not something we're using all day long. So less than an hour, we may be able to go up to a maximum of 12 meters per second squared. So just something to consider, because one thing you're going to, I'll come back to that one actually. One thing you need to consider is that tools age, and specifically if it's a power tool. So what your starting acceleration and vibration measurements are only going to degrade from that point. So we're going to use them potentially in, you know, not ideal environments or circumstances. We're going to start to have machine wear and tear that may cause, you know, increase in vibration. And we also, and then we have kind of the longer the duration, we may actually start to have more disability with using or being exposed to the vibration as the end user. So that becomes a problem when we're looking at, you know, because that's not only going to compromise our safety, but if you have a tool with higher than necessary vibration, then we're going to potentially impact the quality. We may get more scratches or more damage done than good. We definitely will see the increase in vibration. You may have to repeat the work you've been doing because of those quality errors, and it may not work as fast. So we may actually see a decrease in efficiency or productivity. So if you are looking at, you know, interested in, there are hand-arm vibration calculators out there. So you can definitely put, you know, these tools in. This is, again, one done by the HSE. It's a free calculator done online. So you can definitely look at that and kind of show that you have safe exposure levels or not. So just as if you have some of this information available to you and you're interested or you're having tool use, this may be something you're looking at. Okay, so let's put me back on track. So when it comes to looking at ergonomic controls for some of our tool use, so we've talked about the tool handle design, some of the guidelines we talked about, the diameter length, the handle length, contouring and grip surfaces, as well as we've talked about, you know, your table height to be taking into consideration of those tools. But probably one of the best things I have ever learned, and we're talking dollars, maybe even pennies if you have that kind of buying power, but is tennis grip. Tennis grip truly has been, and this is why I was saying you may want to go for a slightly narrower tool, because tennis grip is something that your employees can attach to customize the tool diameter, which is really going to be impactful, as I said earlier, to that grip force that we're going to exert inadvertently. It's a soft grip. It's a non-slip grip, because when you think of tennis athletes, they are definitely sweating. I'm not sure if there's a better way I can say that. It is lightweight. It's usually breathable. So the benefits you really get with this really simple add-on is multi-tiered, and it really is quite inexpensive. And for the ability of someone, as I said, to either put one layer on or 10, if they want to build up that grip strength or build up that diameter, that's their prerogative, and they have the ability to do that. So it's really, truly, when we talk about ergonomic controls, and I say, well, you can't, it's hard to put that name on things, your tennis grip actually really does become one, because the employee can customize it all on their own. And there are different, you can get ones with holes in it, you can get ones that don't. So if you have certain criteria, maybe it's clean, or maybe there's different colors, I can personalize them, different tools, different colors, I don't know, but they really have been something that I have found that employees have just run with and been very thankful of being added into the repertoire of things that they are being provided to kind of make their work a little bit easier. Some of the other things that are a little bit less expensive, unfortunately, are some of your vibration dampening. So the tennis grip absolutely is a vibration dampening option. Specifically, if you're trying to get away from an anti-vibration glove, obviously if your vibration is very high, it's not going to be sufficient. But when we're having that conversation about whether we have grip use or, vibration dampening happening at the source, then that may be an option. The suspension tooling, specifically if it's set at heights that are still going to be within ergonomic ranges below shoulder, then that may be a great option. Always looking for any kind of adjustability. So if you have a task that requires them to work at all kinds, maybe it's your maintenance crew, or whether it be, let's say you have apartment buildings or building maintenance, and they're kind of going into rooms and doing random jobs here and there, and they never know what they're going to be doing, then you can get tools that actually adjust from a pistol to a straight handled grip. And that's a great way of keeping the tool count down in their bag or cart, because that's going to increase forces that they're having to carry, push, or pull, but still allow them that functionability to do work with a pistol grip or a straight handle grip that's going to keep their wrists, straight. Pulsing tools, auto shutoffs, soft grips, and balance tools really is one that I really should have moved up on the list, because I find that a lot of tools, people are struggling with maybe the balance. It's maybe a cheaper product, and it's not as well balanced, or as I said, they've promoted it as something other than what it is used for, and therefore it's not designed with function as its primary objective anymore. So something to consider, because that definitely throws off how the end user is able to use the tool. So at the end of the day, we want to make sure that we have those 4 questions. We want to know the job, we definitely want to know the task, and understand what is the tool's purpose or function. Are we actually getting those first 3 kind of non-user questions answered correctly? Because if not, then we need to go back to the drawing board and see whether a tool is even appropriate in this scenario to begin with. Because if we don't have the appropriate tool, not only are you adding extra cost to your workplace, because the tool replacement strategies are going to be higher, but so are your claims. We need to know the workstation. We need to know whether or not, because based on the tool and the mobility, is it better to be a sitting station versus a standing station? Are we going to be doing vertical versus horizontal plane work? So on and so forth. All of those are going to be going into making sure that you become a really smart tool consumer. Weighing the balances and trying to figure out whether or not we want to use manual or power tools. And then, as I said, I have this in quotation marks, selecting an ergonomic tool. And I don't mean because it has it on the box. I mean because you and your workplace or your employees have trialed it and tested it and have really felt that we have the best tool, not only for the task, for the layout, for the function of the tool, but it's actually going to fit hopefully a large percentage of your users easily and within the guidelines that we've outlined. Okay. So I kind of made some points along the lines of trialing things out. Going into Home Depot and handling things is definitely something we can all do. But if you have a supplier that maybe could bring some things in, if you're looking at trying to figure out a tool to use, specifically if you know you're going to be buying them en masse, then that is never, ever a bad decision. It's a great way to have an integrated, educational, impactful conversation with your employee that's going to allow them to buy in not only to the tool that you're asking them to use, but it's going to help them buy into your program because they've actually been considered in the process. And so always try and do that, especially if it's something crazy. If you're in the meat industry and you're looking at crazy handled knives, because there's lots of different angles on knives that you can get, then trial a few. Make sure that, because maybe this angle of knife works great on this station, but the deboning station, well, you need a different angle for that. And we should not be buying the same one for everyone, even though one person said it was going to be okay. So trial, trial, trial. That's always great. Put some of these questions into your process or your questionnaire, or because, as I said, you may not be the one doing this. It's great that you're here and attending and listening, and I appreciate all of your time. But if you're not the purchaser or the maintenance manager or the inventory keeper of tools and tool use, then how can we as health and safety professionals have some kind of sense that these things are being considered in the best possible way for health and safety? And there's really only way to do that is to kind of put together some kind of checklist or questionnaire that's going to say, have you addressed the function? Have you addressed the task? Have you addressed the layout? And have we chosen the best tool for the user? And maybe even putting some of those criteria that the user has as far as tool length, diameter, and other controls that they maybe could put into there as well. Is there glove use? Questions like that. Because at least then other people are thinking in the same line of thinking as you, and we may start seeing better options being on the floor or in the lab or out in the field. So we also, the big question we need to have is, when are we retiring our tools, which can actually be a huge bone of contention. People that have tool kits are usually very, very attached to their tools and may have had certain tools for 20 years. And that's fine. If that tool is still answering yes to all of our function, layout, user, task questions, then there's no reason for them not to use that. What happens if it breaks and we have to replace it? But more importantly, it's more towards the line of what are we doing for tools that just start to run down. Vibration is increasing, cords are becoming mangled and tangled at increasing forces. There's now splinters in our hammers, things like this that can actually add not only to the ergonomic issues, but also to the health and safety. So we'll often have pre-use checklists for a lot of our heavy equipment and our large equipment. When are we putting the same kind of inspection and maintenance program in place for our more basic power hand tools, or even maybe manual hand tools? Something to consider. Okay, so first next steps for you guys. I always I like to put a challenge forth when I go do my webinars. I'm not sure if Jen and Sarah do them as well, but that's what you get when you get Alex. So I challenge you guys to kind of go around and identify what jobs you have that have extensive tool use. Start with the extensive ones that use them intermittently. They can be on our next wave of attack. And maybe pick one or two of those jobs and go through and do that 4-step evaluation process where you're asking the questions, is our tool appropriate in these 4 categories? And if you need to develop kind of a hand tool checklist, then that's what you can do. We may actually even have one. So if you are interested, you can ask us, and I can definitely dive into my bank of tools and tricks and see what we have available. Definitely look at talking to your maintenance department or the manager of the area that has all those tools happening, and talking about the maintenance program. When is it retiring? How are we maintaining them? What is our process to make sure that we're still using that best tool as appropriately as possible? And use your Google Images. Be on the lookout for innovation, because technology is changing all of the time, and people outside of the box thinking is only getting bigger and better. So what we have available to us today is not what we had 10 years ago, and it's definitely not what we're going to have even next year. So always be on the lookout for those really innovative tools that you're going to be going, oh my gosh. I know, I'm not sure how many people are big social media people, but on Facebook, there's that buzz buzz digger. I don't know. It's some kind of additional ad that comes up online, but some of the innovative things that people have for doing things, I'm like, it's just genius. And you really got to appreciate the minds that go and the thought that goes into thinking outside of the box and how we can do something we've done for literally hundreds of years, how we're going to do it differently and better. So as I mentioned earlier in the webinar, our Industrial Ergonomic Conference registration is open, and we will be having webinar offers at the end of every month. So if you are interested, we will be sending out an email, and if you're interested to get put into a draw for a free registration for the Industrial Ergonomics Conference on June 7th, then please just reply back to the email and we'll put your name for a draw, and we'll be making a draw and letting everyone know who the winner was. So I hope you guys had a great hour with me and that I maybe answered some of your questions that you had regarding tool use. And if you have any others, I'm just trying to bring up my questions. And I can't. Looks like most of them seem to be about my sound. I apologize about that. But as I said, we will be, based on my timing, I don't have a ton of time, so we'll likely, if there are questions, we'll put forth an email out there, and if there's not, then I thank you very much again for taking time out of your day and spending with PROergonomics, and I hope to see you next month. I'll talk to you later. Take care.